Hello everybody, this is a tutorial for my Year 12 Math Method students. This particular tutorial is about domain and range, DNR, domain and range, and primarily covers some of the exercises from 1B in the text. That's what I aim to do in this presentation. Now there are a couple of things you should remember when you're doing this. Whenever you have something under a square root sign, say x plus 1, anything under a square root sign should always be greater than or equal to 0. So then you could say, well, x has to be greater than or equal to -1. Now that's important if you're having to figure out the domain and range of a function where you have a square root. Now, on the other hand, if you have a fraction, something like this, anything under a fraction can't be equal to 0. So if we say x plus 2 can't be equal to 0, and then we take that 2 across to the other side, we can say, well, x can't be equal to -2. Now that's important for calculating the domain and range. So remember those two things when you're working on some of these exercises in 1B. Alrighty, let's get cracking on a problem. Okay, so what we've got to do now is to find the domain and range for this particular parabola here. Alrighty, well, if it helps, you can sketch it. Now, if we have the y-axis up here and the x-axis down there, this is an upside down parabola, and its turning point will be up at 0, 4. So it'll go down like this. Well, that kind of helps us out with the domain and range. So the domain could be any real number. We could put any value for x in there and we'll get out a y value. Now, with the range, we can only get values less than 4. So it would be from -infinity up to and including 4. So that'd be the domain and range for this parabola. Alright, just remember, it helps sometimes to sketch. Okay, now the domain and range of f of x, where we have 4 minus x plus 1. Well, there are a couple of different ways you can do this. I suppose you could sketch it. But what I'd probably do, given that we have a square root, I'd say 4 minus x always has to be greater than 0. Remember, when you have a square root, anything under the square root must be greater than 0. Now if I took this across to the other side, I'd get 4 must be less than x, and I could rewrite it like this. We can put in any value we like for x as long as it's less than or equal to 4. Now that helps us out with the domain. So we can say the domain would have to be from -infinity up to 4. Alrighty, now let's see, if I were to sketch this graph, and maybe that might help me a little bit, if the values always have to be less than 4, I can say, well, it would be up here. It would be from 4, kind of going back in this direction, and the plus 1 moves everything up 1. So our graph would go something like that, and there's y there and there's x there. So I could say the range is from, let's see, -infinity, oops, my mistake, the range is going from 1 up to infinity, so we could say we need from 1 up to infinity, and that would be the range. Alrighty, let's try the next one. Okay, here's one that's more on function. So if we have some function here, it's a linear function, f of x is equal to 3x minus 1. Then find the image of 3. Now what that means is that if you put in 3, what comes out? So that would be 3 minus 1, well that would be 9 minus 1. So the image of 3 is 8. Now down here it says, what is the pre-image of, I suppose I should have chosen another one. So say we chose find the pre-image of 14. What that means is we want to know what x is if what comes out is 14. So in place of f of x, since f of x is equal to 3x minus 1, we could say 3x minus 1 equals 14, which means 3x is equal to 15, which means x is equal to 5. So if you kind of wanted to remember, you could say the pre-image goes into that function, and out comes the image. Okay, now here we have f of x is equal to 4, so what happens if we plug in 4? Well, that would be 3 times 4 minus 1. 3 times 4 minus 1 is 12 minus 1, which is 11. So f of 4 is equal to 11. Now what happens, what value do we need to put into this function here to get out 20? So we could say, well, that will be 3a minus 11, because a replaces everything where there was an x, is equal to 20, and we could say that would be 3a is equal to 21, so a is equal to 11. Now what happens if we have this one here, e? Okay, well, whereabouts is f of x greater than x? Well, if we said in place of f of x, well, that's equal to 3x minus 1 is greater than x, and we took a minus x from both sides and put a plus 1 onto each side, we'd get 2x is greater than 1, which means x would have to be greater than 1/2. Okay, let's try the last slide now. Okay, find the domain and range. Now this, even though it might not look like it, is actually a hyperbola. Now the way we can make it look more like a normal hyperbola is if we divide one by the other. So x divided by 2, how many times does it go into 4x plus 7? Well, it should go in 4 times. So 4 times x is 4x, and 4 times 2 is 8. Now when we take them away from one another, 4x take away 4x is 0, 7 take away 8 is minus 1. So we could rewrite this, if f of x was equal to 4x plus 7 over x plus 2, we could write this as 4 and minus 1 remainder. Now this looks more like the ordinary hyperbolas that we're used to. And we could also say now, using the logic that we had before, anything on the bottom of a fraction can't be equal to 0. So x can't be equal to -2. Now that's important for the domain. So we could say the domain was all real numbers except for -2. And the range, well, see how the range has moved up 4? So we could say the range is all real numbers except for 4. And we could just check that out by drawing a quick sketch. Now, we know that the hyperbola would have to be at -2, and we know that the 4 here has moved everything up 4. So there would be hyperbola across there at y equals 4, and since our hyperbola is negative, it would have to be up like that and down like that. Now it can't have any x value at x equals -2, and it can't have any y value at y equals 4. Alrighty, well I hope that helps with some of the exercises you'll be facing in 1B. If it doesn't, tap me on the shoulder in class and I'll try to help you again. See you in class.